Hello dear students, today we'll talk about the volume strength of hydrogen peroxide. This is a common way of expressing concentration of hydrogen peroxide, particularly for commercially available solutions. For instance, while looking at the description written on a reagent bottle, we see that it shows 20 volumes. This 20 volumes of hydrogen peroxide represents the volume strength of hydrogen peroxide. Now, how can we define this? So we say it is the volume of O2 gas released when 1 unit volume of hydrogen peroxide is consumed at standard temperature pressure. For example, hydrogen peroxide upon decomposition gives us water and oxygen gas. Now, if 1 ml of hydrogen peroxide is consumed and it produces, suppose V ml of O2 gas at standard temperature pressure, then this V ml of O2 gas, we call it as volume strength of hydrogen peroxide. Thus, we can say that 20 volume of hydrogen peroxide means that 20 ml of O2 gas is produced from 1 ml of H2O2 at standard temperature pressure. This is the definition of volume strength of H2O2. Similarly, if the reagent bottle depicts 30 volumes of H2O2, that means 30 ml of O2 gas has been produced from 1 ml of hydrogen peroxide at standard temperature pressure. Now, what is the relation of this volume strength with molarity? We have the decomposition of H2O2 as, in this, 2 moles of hydrogen peroxide produces 1 mole of O2 gas. This implies 1 mole of hydrogen peroxide will produce half moles of O2 gas. Now, converting the moles into volume at standard temperature pressure, we can write 1 mole of H2O2 will be equal to half into 22.4 liters of O2 gas at standard temperature pressure, and that comes out to be equal to 11.2 liters of O2 gas at standard temperature pressure. Let's keep this equation first. Now, if molarity of hydrogen peroxide is taken as m, this means that 1 liter of solution contains m moles of hydrogen peroxide. Therefore, from equation first we have m moles of H2O2 will be equal to 11.2 into m liters of O2 gas at STP. Now, as we know, volume strength is the volume of O2 gas produced at STP. Therefore, volume strength will be equal to 11.2 into m, and m is the molarity. This is the relation of volume strength with molarity of the solution. In the same way, the relation of volume strength with normality is given by volume strength is equal to 5.6 into n, and n is the normality of solution. Now, let's explain it in terms of an illustration. Express 20 volume H2O2 into molarity. Since we know volume strength is equal to 11.2 into m, this implies as volume strength is given, that's 20 volume, so we have 20 is equal to 11.2 into m, which implies m will be equal to 20 by 11.2, which gives you molarity equal to 1.785. This is how you can convert volume strength as a concentration term for H2O2 into molarity. In the same way, you can convert the volume strength in terms of normality by the expression given above. Now, I'm asking you to express 20 volume hydrogen peroxide into percentage. If you like my videos, please do not hesitate to subscribe. Thank you.